Hi, everybody. Welcome to today's session on next generation intelligent infrastructure. Joined with me is Shawn Meyers, and I'm Rob Girard, and we're going to walk you through Tintri integrated storage and show you how intelligent infrastructure can change your life as a DBA and allow your organization to do way more than it's doing today with less. So what are we here to talk about? So first off, we're going to cover why intelligent infrastructure and AIOPs are important. Now, AIOPs, if you're unfamiliar with the term, refers to operations that are driven by artificial intelligence. So artificial intelligence operations, the concept of having lots and lots of metrics and big data, and then letting some AI go and drive that to take care of the mundane tasks for you. So, why it's important, what it is, and what it can do for you are what we're going to cover in this session today, as well as some demos on what Tintri provides to allow for this. So, joined with me is Shawn Meyers. Introduce yourself, Shawn.
Sure. Thank you, Rob. I'm Shawn Meyers. So some background on me, I became an actional DBA back in 1995. I tell people that I've been working with databases since '82 because my dad was a developer and he made me learn how to work databases back when I was a kid, and I had to build a database for my mom's Hummel collection. So I'm getting close to 40 years of database experience. But I've been a full-time DBA since 2003. I've got lots and lots of initials, but I don't like to list them all out. And some of them have expired. I've also been a speaker at SQL PASS Summit, SQL Bits, VMworld, and many different SQL Saturdays. In my current role, I'm a Field CTO Tintri, here to talk about basically how databases and infrastructure need to merge.
Thanks, Shawn. And myself, I'm Rob Girard. If you just look to the bottom, I've got a bunch of initials there, most of which are all expired, especially that MCSC NT4 in 2000. But that vExpert from VMware is recent. I do have quite a track record of in the trenches experience in infrastructure starting in 97 and moving at 16 and a half years into that before I transitioned over to the vendor side, where I joined Tintri as a technical marketing engineer. And that's a fun role for me because I get a lot of lab time and I get to work with a lot of different customers and prospects and see a lot of different environments. So I have a lot of exposure to a lot of environments, and I have the time and resources to go and test a lot of the things that you'd love to test yourselves, but don't have the time to do. So, today, Shawn and I, we've presented many times in the past, lots of different VMworlds. We've presented SQL PASS Summit together. But this is our first official, tag team remote presentation. So bear with us here. But over to you, Shawn.
Sure. So first, we're going to talk about, obviously this is a fun slide, just, what database administrators. And my favorite part, like what my mom thinks I do. My mom thinks I work on computers. But what I really do, of course, is, especially in the world of COVID and how things are, is just a lot of stress and just trying to do things remotely. But next, the next two slides we're going to talk through is actually going to be perspectives about how infrastructure and storage works from a DBA, and then also for how the infrastructure admins look at that. So the first thing we talk about is time and skills. It's not going to say a lack of skills, because DBAs, we all have massive skills. The problem is we don't have great skills when it comes to storage. We want storage to be like an iPhone and just work, no longer having to think about it. The problem is it doesn't always work that way. So the DBA, we have to go learn about storage. And then, of course, if we have those problems and it persists for a while and we have some issues, and then eventually you get to that meeting. What I mean by that meeting, anybody who's ever worked for storage vendors will know this meeting exists. It's you get the meeting with the DBA, the storage admin, the Windows admin, the virtualization admin, the network admin. We all get in a room going, okay, we have a problem. We agree there's a problem. Let's solve it. We all sit in our laptops. We type away for a while. We go, yep, it's not me. It's someone else. And there's some finger pointing. Sometimes there's blaming, this different stuff. Those problems do take a fair amount of time to solve. One of my previous lives, I used to be a consultant. I had to come in and mediate these meetings for many organizations. And that's why I mean a lack of time and skills, because no one has that kind of time to sit around in these meetings, and then again, the skills from the big picture of how to understand the whole stack to figure out where the problems are at. And then we have database slowdowns. We use DBAs. We have data protection rules. We have to refresh test dev systems. We have to do maintenance. And we got to do all this while not slowing down production. And how do we do that? Because most cool things about this, all those things we have, all of those impact my production speeds. Especially every time I'm doing a backup, I have to do them in maintenance windows and schedules out. Can we do these things during the day without impacting performance? We'll show you some options for that. My favorite thing about waiting on other staff. So got a database, we're doing our job, we're tracking performance, we're tracking space utilization, and go, hey, we actually had a very large ETL this weekend. Normally we import 10 gig. For some reason this time it was 150 gig. Don't know why, but now we're very tight on space. And if we do another 150 gig this weekend, we're going to run out of space and the database is going to stop. That's bad. Plenty of time. We go ahead and open the ticket system. We enter a ticket. Hey, we need to expand the drives on this database SQL Server. No big deal. It goes off to the storage admin. Storage admin looks and goes, yep, the disk pool is fine. We can expand the disk pool. And then goes, yep, the LUN is fine, and goes extends the LUN. Forwards the ticket on to the virtualization admin. The VMware admin looks at that and goes, oh, no big deal. We go ahead and expand the data store for that process. And then I go in and expand the VMDK. Then forward off to the Windows admin. Windows admin logs in a disk management, goes in and goes, hey, now I can go ahead and expand the drive. So now the space is there. Sounds simple, except if you work for a mid-sized or large organization, that may be a 2 or 3 week problem, or amount of time between the time that starts to the time that last ticket's finished, because it's one ticket, but going through multiple different groups and multiple different queues. All right, I know I may run out of storage this weekend, so I now have to do a escalation. Now I have to go fill out a form and have my VP sign it, and then have this ticket escalated. Lots of extra hops and lots of extra work for something everyone can agree is a really simple problem. Why do we do all these things? And then inadequate visibility. What we talk about here is DBAs. We have the DMV virtual file stats. We can go look at what's going on inside a SQL Server, where my slowdowns are at, except that virtual file stats only gives me point in time, and it doesn't give me actual what's going on. It gives me a counter since last restart. I can use perfmon and some other things for it, but I really don't know what's going on with my systems. And so what happens is I end up using different tools or third-party things, or I have to rely on the virtualization admins or the storage admins to give me visibility, and they can't do it per database. They can only give me things overall big picture. So we don't have great details or granularity on my pictures of what's going on with each database. And then unpredictable performance. If I happen to have one SQL Server database that's running really, really hot, it may impact the same databases on the same server. And so there's no way to guarantee each database to get its own throughput processes. So one bad query on one database can impact multiple other databases.
So Shawn, let me take this one, okay? Because
sure.
I mean, you are a DBA by trade, and I am an infrastructure admin architect by trade. And so let me just defend myself and the other infrastructure admins out there. So when you as a DBA come to me and you say, hey, Rob, we really need, it's going slow, whatever that might be, I'm going to start looking in through all the logs to defend why my infrastructure is running smoothly. And I'm going to start looking now in the best case scenario where we don't have the large silos of large enterprises, and you are lucky enough to have sort of a jack of all trades that can do all of these things. All of those things that you described around provisioning that storage and all the various levels of expanding a LUN and expanding the data store, maybe that doesn't have to bounce between a bunch of teams, but it may be all within one person, and it's still a lot of steps, and any one of them wrong gets in the way. So each of those layers that we needed to go in to expand things, this is where we got to start looking through to figure out if there's any issues at all of those layers. And as I'm going through, I'm trying to figure out that, hey, no, my infrastructure is solid, and I have a tendency to look for and cherry pick good data. So, hey, my storage tells me it's, 0.5 0.8 milliseconds. So right away, it's not the storage, and typically there's a much bigger story to that, and that 0.8 may not actually represent the database object itself. That could be very representative of maybe the average of everything. So where Shawn is being impacted as the DBA, where he is feeling the pain of an infrastructure pain point to that database. As an infrastructure architect, I'm struggling to find his database in there. I might be able to find his vdisk. I may have carved out a particular LUN for his database, so that gives me more visibility. But on the quality of service, I will struggle to try and give that database and stand by and say, yeah, no, guaranteed it's going to be great, and nothing else is going to bother it. And if I am able to achieve that, it is very much a pet type scenario, and that doesn't scale very well when you have tens, hundreds, thousands of databases in tens, hundreds, thousands of database servers, plus all of the clients and applications. So it really gets confusing. Now, I'd love to help out the DBAs more and do some more data protection, help them with their DevOps workflows. But if any of that stuff is obfuscated from me because it's hidden inside of other disks, and when you talk that database, sorry, I need to know, what server are you talking about? Anyway, there's a kind of a disconnect between us, and I'll do my best to try and get this running smooth. But again, it just doesn't scale, and it's not as easy as finding a particular database and just knowing, hey, this is the overall performance for it. And what we want to do is just go into a demo right now. And what I'm going to show you is a different approach using Tintri VM stores with our new Tintri SQL integrated storage feature that's actually going to go in and show us our databases. And within these databases, all of those things I just described will not be a non-issue. And here we are with our SQL Management Studio connected to Lenovo SQL One. Just going to refresh this database, make sure there's nothing hidden under here or the same names I'm about to use. And I just want to create a new database. And really simple, I've got a default file location for this over on File Share. And this file, all the magic of the intelligent infrastructure is going to map it into its own storage space automatically and identify it. So I'm just going to say one database. Okay. And of course, you can do whatever else you would normally do when you're creating a new database. And so now we've got a database that we can use. I'm just going to use another tool to create a different database. So, if I'm not using SQL Management Studio, this one, HammerDB, is going to create a database and populate it. And this is just used for tests. So I've got a few of these in the background, just running some light load as well. And so here I'm going to connect to Lenovo SQL One. And I need to give my database name. So I will give it a name of AABits 2020. And I just AA so that it pops to the top of the list. It's nice and easy to find. Some random number of data warehouses and users. And then off we go and build. Are you sure you want to? Yes. And from here, check if it create exists. And from here, we should be loading the items. And at this point, it is now, filling up these databases. And so just to confirm, if we look at our SQL Server here at our databases and refresh on the right one, here's our one database and our AA bit. Now let's go over to Tintri Global Center. This is the management tool to see into all of our storage. And these are some key highlights that are happening live across the various systems I'm connected to. Not too much. I'll cover this in a sec. So let's go over to this Databases tab. And what we can see in here is one called One Database and one called AABits 2020. So we've already discovered it. Now, we don't have stats for it yet because it's a net new object. But just because we don't have the stats yet doesn't mean that it's not already usable and functionable. So if I were to look at the databases here that are in here, that shows that there's 109. I can see things like, hey, are any of them having trouble right now? And so I can look at this, sorting by latency, high to low. I can see that our heaviest hit latency, our database with the most latency at this point right now is this one called prod AW DW 2017. So it's a clone of an AdventureWorks one. So we've got a bit of network latency and a bit of storage latency. And the storage latency is primarily because this one's on an older hybrid. And we've got some all flash in here. The ones that I was just deploying to are this EC6090. And we've got just some light load working through here. And on each of them, we can see this breakdown of latency. So that finger pointing is now gone. We can easily see if there's an issue, where do we blame? Now, this is fine when I want to look at one. I can drill into a single one, look at the last day of what it's been doing, or I can go into the metrics here and see if it's had issues for quite a while. And we can look at our, let's take a look at the last week on this, and very programmatic in nature. And we can see that this is what it's doing from an I/O perspective. And I can look at things like the latency and see if it's been having a good day, yes or no. And way back in the past here, there's actually a spike. So let's hone in on that. And we can make it easier to see that this is this spike here, 300 milliseconds of latency. However, this is not storage latency. This is from the network. So there's something wrong with our network config. And I can see through the graph that it shows up from time to time as network latency. So this is an example where something's not right and we got to fix it. And we can know this because that we've mapped everything automatically in the back end, and the storage itself is isolating it and providing protection and doing a lot of other great data services with it. So now that's great when you know what you're looking for, or a spot check of right now. Let's take a look historically. Let's just take a look at, say, throughput, for example, across our environment. It's got a few hundred or thousand VMs and databases in it. And let's just take a look at the past week. That's a throughput graph. And so we get some peaks here, somewhere, 1400-ish megabytes per second. Not, lab environment, so not super busy. And our latency. And I can see here that we've got some hotspots. So here's a hotspot on some, say, network latency. And this was happening at noon. And we can see that this one database is a clone of that other, was getting a lot of latency. And it was, and everybody else was latency free. And now we can look into that database and go through and figure out exactly where it was. Now the storage latency actually varies based on how much it's used. So the more it uses it, the more reserves it gets on a Tintri VM store. And this intelligence is what allows us to start any big workload and protect everything that's already running without having to set up any kind of manual tuning for LUNs or volumes. It's just really set it and forget it, and great visibility. All right, so back to the presentation.
Thanks for that fantastic demo, Rob. Very insightful. We learned a lot.
You're welcome.
So now we're going to talk about how the VM store concept actually works. There's a lot in this whole process, and we're going to go through a lot of things fairly quickly. So we're going to talk about storage before consolidation or virtualization. And I say consolidation because back when I first started as a DBA, we tended to have one database per SQL Server. And then, of course, we went through a consolidation projects because we needed to run out because SQL Server licensing was expensive. And we added multiple databases, which changed I/O patterns per databases. And then, of course, we did virtualization. So now I have more consolidation all in the same place, which helps obfuscate how my storage actually interacts. So let's go back to the days when things worked very simply. So shared storage arrays are a microcosm of the data center, an aggregated pool of CPU, memory, storage media, and network connectivity, assembled for the purpose of providing storage to other services in the data center. Historically, in support of these services, the primary mode of consumption has been the LUN. And we configure the LUN as a dependency's understanding of the capabilities of your pool of storage resources and the understanding of the requirements of your database running on a physical server. Properly configuring these was an exercise of translating the needs of the physical server to the database, to the data store, to make it all work properly. And then we just scale this out as we needed. We had more databases, we add more database, more LUNs and more configuration processes, and we just continue to scale as we needed. Of course, then we had, and the measurement of telemetry at the LUN level was sufficient to give us great insight on what's going on per database, or understanding what that SQL Server was doing if I had multiple databases. And we could tune and tweak as we needed, because there was a one-to-one relationship between the consumption of the storage and the use of that storage. So now we did your consolidation. We're going to do consolidation and virtualization, because what happened here then, I now took all these things, and I had these physical servers before. I replaced them with now virtual servers. And then also with that, I put lots and lots of different SQL servers on top of those virtual servers. And inside of each one of those, there are actually databases in here. And now this basically doesn't give us the great insight we used to, because now we have multiple paths back and forth to the storage and no single point to look at. And of course, these databases are still, these virtual machines are now files, and inside those files are actually more files. And so there's no way to understand the I/O patterns for the database file inside a virtual machine anymore. How do you correlate what SQL Server A to which file where kind of stuff? And of course, if from a database level, it's even harder to troubleshoot or to understand this concept. Not to mention, if we actually do storage motions, between our live migration, I can move the data files between, the VMs between different data points. And now I even harder to figure out where things are at. This also explains why some things worked yesterday and don't work today. And then try to constantly untangle this can consume up to 95% of the operational overhead as managing storage systems for SQL servers, because there's just so much. And then, of course, let's go ahead and try to correlate where database C is actually residing at, or D, and these kind of concepts. And then, of course, the infrastructure and operations teams are blindly looking at things, often trying to, with less visibility than they had pre-virtualization, and trying to solve these problems. We did, obfuscate a lot of this by actually just getting really fast storage, but that doesn't mean the problem went away. It just means we just obfuscated the problem. We kind of covered it up. So we had to implement things like monitoring tools, and then management tools, and of course, even more automation tools to help us dissolve all these problems. So all we did was stack things up. And then, of course, that allowed us to add more things. So we just had more virtualization hosts and more SQL servers. And so we got a larger picture.
And I guess on this one here, that at the very bottom down there is the amount of innovation in here. And I guess after we've exhausted all of our time with all of those tasks for setup and sizing, performance and management, all of that, after we've taken care of all the basic stuff, then as DBAs, as infrastructure architects, this is our opportunity with all this amazing free time, which is probably a deficit, to input our innovation in that actually helps the business.
And then we had this paradigm of siloed staff with some finger pointing. As we talked earlier about this, we'd have these people work with different layers of it, and the issue going back and forth, and find out sometimes it's eating the circle, because the worst part is being in that meeting, being the DBA, and finding out actually it's your database design. I've been there, done that, and it's always embarrassing, which of course means next time we have the problem of, oh, we're not going to trust you, which makes more silos and more difficulties. So again, if we can find out these information and solve it easier or have better insight. And how we're going to do that, we're going to talk about the Tintri VM store. Rob's great demo we just had earlier, but we're going to talk about how that system can solve most of these issues. With our focus on solving issues created by repurposing LUNs to support SQL servers, compounded by the breadth and scale of consolidation and virtualization, SQL servers in a modern enterprise, VMstore is built on the foundation of commodity hardware. Our foundation is the Tintri OS. This allows us to have everything so we're not, so I can understand databases and database files and not trying to understand LUNs or volumes. And it's built around a core of monitoring and automation and management built into the system, which can support dynamic churn for large-scale SQL enterprises. The VMware solution is easy to deploy, so it's able to go from the box to production in under an hour with no professional services needed. So we can go ahead and remove that setup process, make things simpler. These principles have led us to develop the appliance so we can without boundaries to think differently of how we want to do stuff. And of course, the VM store is consumed as a single pool of storage. No more needing to carving up LUNs, which then we have to carve up into data stores, which then carves up into disks, and then bounce things around that and put logs and data in different places, and all this process. We just put it all out there, and you put the data out there, and now we're managing at the unit, i.e. the database file is being managed, not having to bury that database inside of a disk, inside of a data store, inside of a LUN. We have a direct one-to-one from that database file to the operating system of the storage array. Plus, the VM store integrates directly with the SQL Server to pull activities, to apply information, allowing us to do granular access on understanding how these things all work properly, and then allow us to have those SQL servers to provide us hypertextual management to allow us to do snapshots, replication, and synchronization processes to other storage arrays, all at a per database level, not having to resort back to the LUN level. Also, we can monitor and data file usage and capturing read-write percentages, IOPs, block sizes, and other critical telemetry per SQL Server database. This allows the array to tune based upon I/O patterns, meaning we can have great per database information now and understand how each SQL Server wants to utilize these data files for each database. With this, we also allow you to do QoS, meaning we can actually provide quality of service per database. So that way, when I happen to have one database on one SQL Server that runs a really big query, I can now have it not impact other databases on the same SQL Server or in the same ESXi or virtualization host or any other facets. Because now, even though I have shared storage, I'm now able to reserve enough resources to allow other systems to work. And then, of course, resolve this data calculations as autonomous actions, which is the ability to expose insights into where latency can lie within the rest of the ecosystem. So we can monitor what's going on from here, see how the IOs are going in and out of the storage system. Is the disk pool having issues? And visualize all this information, and we'll be able to show you a demo of this and provide what's going on with this information. This allows us to autonomously make recommendations and or changes to the storage system to allow the latency to be addressed. So making sure we're trying to provide 1 millisecond storage to each of our databases. And all these behaviors and actions can be taken at the per database level. And then we have Tintri Analytics, which is the place it plugs in. And Rob, you want to talk quickly about Tintri Analytics?
Sure, I'd love to. So we have several layers to Tintri Analytics. We've got the VM store itself, which is the hardware array that has a whole bunch of telemetry and has a lot of those rules to manage the performance and do that auto QoS or manual QoS. And that bubbles up in through Global Center to let us hold this data. Instead of 7 days, it goes 30 days. And all of this comes up into Tintri, and we have Tintri Analytics, which is a software as a service portal, and so customers then log into Tintri Analytics, and this is where they can see their 3-year trending and sizing. So this is you can see what has been consumed. We can do simulations. Down at the application level, at the databases, and we can do some like what-if scenarios of, hey, we're going to add more databases. Can our environment support it? And instead of having to know whether or not it fits and what those I/O requirements are, we can take known databases that are already deployed and say, well, it's going to be similar to these ones, and we can lump those together as a customized application group, and then just model out adding more of those and whether or not we need to add more hardware to the picture. And so this not only does it help with sizing going forward, we've got Advisor built into analytics, and so using all that granularity way down that started at the bottom, it tied that granularity into objects that we care about, which are those virtual machine files and the database files. They gave them the identities we care about. They bubbled all the way up. And with advice here, we can now make actionable advice and do the legwork automatically through some AI and machine learning that we've got running in there that then brings that forward and it's like having extra staff members analyzing things for you and then giving you nice clean advice on hot spots to worry about. You're going to run out of performance or space, so you can stay ahead of it. Now, by doing all of these things and abstracting out all those layers of the management and the automation, et cetera, now you, the DBA, the infrastructure admins, you have much more time given back to you to focus on the last piece, which is that innovation. So as much as our innovations have gone and helped, you can focus on the innovation on your side, and your administration portion is now flipped. So instead of the majority of the time being this administrative burden just to store the stuff and make it reliable, that part is now taken care of. That's just table stakes. And now your job is doing better, cooler, smarter things through innovation.
Thanks, Rob. So with the VM Start ecosystem, all these behaviors and actions have been taken at the per database level. And we've already talked about all this already, but now I can stack this across multiple different systems as we scale out. And of course, I put many, many different databases in here. And then I've got gobs and gobs of databases. Any large organization, you have hundreds, if not thousands of databases. And then this way I can mix them together and I can manage them here properly and still be able to determine what each of these databases is going on and provide performance QoS so each one gets the resources it needs to have, which is what we're talking about. And this helps remove a lot of these operational burden problems we've already talked about multiple times. End of the day, as we talk about intelligence, the ability to acquire and apply knowledge and skills. And so intelligent infrastructure basically has to use a lot of things to acquire the intelligence, but then to go ahead and how it applies that to make your day better. All right, so now switching topics. So why intelligent infrastructure? And now you understand what that is. And then AIOps is important. As we've already talked about, in the past, we've got things going on. Most organizations have more and more infrastructure. In every report you read, we're going to have more things. We're going to have more infrastructure out there. The problem is budgets and people and staffing, those lines are flat. In fact, they may be going down. So we have more things to manage and less things to take care of. More things to take care of, but less time and resources to take care of them. So we have role-based automation. This helps with lots of different things and makes systems run better. The problem is there's a gap between the growth of infrastructure and how much time we can use with roles-based automation. That gap will have to be filled out with intelligent infrastructure and AI operations. This is the way we can allow more things to be managed by fewer and fewer people. So the short version of what intelligent infrastructure is, we're going to do more with less. At the end of the day, we're going to make more copies of databases in less time. We're going to solve all of our problems, performance problems in less time. We're going to deploy more copies for much less space. We'll be able to use more testing integration with less deduplication of efforts. And they'll think of QA regression processes going much faster, shaving your QA testing cycles from 4 weeks down to 2 weeks or 2 weeks down to a day, for application development processes. And more application testing with less staff. And deliver more innovation with less money. And you can make up your own version here, or your boss who may be watching the same video at the same time with you has made up their own mind as well about what things you can do with this.
So, John, let's just stay on that slide for 1 sec here. On the deploy more copies in less time, just from a tactical perspective, what are we talking about? So we could clone a database to create a copy of that database. Now, if back up a few years or maybe currently in your environment, that meant backing up that SQL database, which is a lengthy process, maybe disruptive, and then restoring it somewhere, transferring it, and then restoring it. And that backup process, let's say that we could read it off at, say, a gigabyte a second, and this was a terabyte, well, that's 1,000 seconds just to get that first backup of it. Okay, I got an even faster array. It does it at 2 gigabytes a second. Okay, great, you're at 500 seconds. You can see that faster and faster isn't going to be enough to shrink that time delta to next to nothing. And I'm bringing this up because when we're cloning databases on a Tintri VM store, regardless of the size, we're looking at somewhere in the neighborhood of 3 seconds for that database to be ready to go. So what would that do to give you time back, right? It's not just that something else is doing it in the background and then you're doing it. The moment someone wants that, they actually get it. And there's without applying intelligence behind the scenes, there's no way to do this through brute force.
All right, and Rob, here's the next demo for you.
Oh, me again? Great, thanks, Shawn. Okay, so demonstrating that how we can intelligently clone instead of using brute force techniques. Let's just go in and find a database worth cloning. I'm going to search by size because I want to pick on one that's large. And let's pick on, well, this one right here, WDemo, looks good to me. It's 300 gig in size, and it lives on Lenovo SQL 1. So let's just take a look here and confirm that it is in fact the one we're looking at. We've got one here called WDemo. Just look at properties, and we're going to confirm that it is in fact. So that physical size at 300 gigs, it's actually, that's 300 on disk after some space savings. It's actually about 500 gigs in size here. And so this seems like a perfect candidate. And we can see files here that this sits out on / and then this is a different Tintri VM store. So let's go find that WDemo in our interface here. And what we want to do is we want to take an action on it, and we want to clone it. And we'll call this the WDemo, let's call it the WDemo bits clone. And we'll take a snapshot of it right now as it looks. And then we will go and put that over onto the same Lenovo SQL 1, and we choose a share that goes into it. Now we can create these shares and permissions on them so we can see some and not others. So I'll put this one off in this DB share, and then I'll just say clone. And by the time I can get over to my SQL Server and refresh here, I will have a complete copy of this here, WDemo clone. So that was 500 gigs already ready to go. And it's perfect. But hey, what if it's going to go onto a different server? No problem. Let's pick on a different one here, and we'll do the same thing. So if we've got one that's active, we can choose it instead. This one here is Prod AW DW 2017, and it is on a J50 on a hybrid. Sure, okay, let's pick on it. This one, dev plan, yeah, so this one, physical size, okay, 86 gigs, that's big enough to pass the test. Or maybe this one here, that's 150 gig, a little bigger, just, and that's on 5080, it's called human resources. So we just want to take this, and we can see that it lives on Lenovo SQL 1 right now. It really doesn't matter where it lives right now, it matters where it's gonna go. We can see this is one that has some activity on it. And some nice low latency on it. And so then we're just going to take this actions. Now these cloning actions, I'm doing the UI, but we can use REST calls and we can use PowerShell toolkit. And we don't have to figure out which LUN it's on or what server it's on, any of that. We just, hey, this is the database I want, and where do I want it to go? So we're going to clone this, and we're going to call this one HR on dev. And we're going to pick on a share for it, and we're going to put it in this DevDB share. And we're going to create a new snapshot now, or if we had any existing, we could just clone from that, which is great for recoveries. And so now here's that HR dev, and we're going to put it onto, wait, I don't want to go same server. Let's find one of our dev servers here. RG 2016 dev, perfect. And off we go, clone it. And we look over here at our RG 2016 dev, and we refresh it, and here's our HR dev, and this thing's good to go. Now, this isn't the only cloning technology out there. There's lots. However, this is the only hardware-accelerated cloning technology done at this database level. So this is the first of its kind, and this hardware acceleration means that we don't have to worry about these behind-the-scenes software linkages that may bog down your original database or create some ties to it. All of the ties that are created are under the covers. It's totally protected, so that now that I've got this HR dev database, I can do something with it. So let's go find our new HR dev database in our, go to our database here, and let's just go to our filter. And what was it called? I remember it had dev somewhere in the name. And oh, there it is, HR dev. So now we've got this. We can go in and we can clone it again, treat it just like another, and we can go in and we can create things like a protection policy. So we can snapshot it every 15 minutes. We can, have some hourlies and dailies in there, weeklies, monthlies. These are all done in a very fast manner that does not involve talking to SQL Server. So this is patented technology that Tintri has that can make this clone very fast, no stuns, and your data will have complete integrity. So we'll take this. We can then have that clone replicating somewhere else. So another site can use it for DR, or other developers may have a copy of it. And we can also set some quality of service on this so that if we didn't want the manual QoS in, we could guarantee reservations. So if this was a nasty database that normally hurt our server, we can actually slow that down to the storage side, even though our store procedures and stuff inside may not be able to slow down. And if I can just continue on one more step beyond actions, it is the longer term stuff. So this is our Tintri Analytics. This will give us a 3-year look at things, and this is the storage in our environment. And what I want to drill into here is that I can click at any point in time that might be interesting, like this performance spike, for example. And this is a distribution of all the VMs, all the databases on it at this point in time. So if I click in here, some outliers, so my I/O performance along the bottom is the number of performance units. I could go by throughput. Maybe that's a number that people can relate to more. And so here's one that was had what we call a peak busy hour on that day at 532 megabytes per second. This was the 10-minute averages over the course of an hour. So in the peaks, it would have been quicker than this. And we can see that this is the database. It's a database called TSYS LS Test, so a log shipping test database. And we can see the VM store that it's on. And now if we've got a bunch of databases of interest, we can refine it and say, I've already created a group here for AdventureWorks. And so of all the AdventureWorks databases that existed at this time, here's a distribution of their profiles. And so if I were to go to trends and take a look at this, I can see that our AdventureWorks database started October 25th, which, no surprise, is right around when Shawn Meyers joined us and started creating some AdventureWorks databases. So instead of all the HammerDB ones I did, he's going with the ones that you're familiar with, running a bunch of test scripts and stuff on them to really kick the tires on this. And he had 3 going, then 2, and you can see this blue line where he was peaking at, Shawn, 12 AdventureWorks databases. Nice. Okay. You just can't have enough of a good thing, I guess. So we can see that easily. We can see the space for it. We can look at a lot of other metrics. We can drill down and see exactly who's taken that space. We can drill in here. And the biggest ones at 1.3 terabytes are this AdventureWorks 2017 on a T850, which is a hybrid. And we may have another one here, which is over on a T5080. And so this gives us great visibility going back 3 years. We can see our growth, and then we can go to our planner, and what we can do is take our current trajectory of the environment and model things like deploying new things. So I want to deploy new objects. I can deploy them off into the future here at mid-October, and what kind of object do I want to play? Well, I bet you October's coming around, and Sean's going to want more AdventureWorks databases. So, does he want one? No, he probably wants another dozen. And what will that do to the overall environment? And as you can see, this environment will easily handle it. And if we were to not look at all of our VM stores and just focus on one of them, for example, because we didn't want it spread across all of them, we can see that even this 16090 could amply handle it. We can see the increase of performance after that's put on. We can see that that'll ramp up. And this one doesn't have too much growth going forward, but if this wasn't a lab, you would see that most of these things trend forward. So that's the demo in a nutshell. I could spend hours and have in the past showing this stuff because I absolutely love it. But you owe it to yourselves to get this technology. And back to our presentation, and we can continue on.
Fantastic demonstration, Rob. I mean, cloning that database that fast. I mean, just how much time that will save for any of us, or even those who have those funny scripts that we do that backup restore every night to the same process. No longer coming in the morning, finding it's broken. I can just now do it in seconds. Or even better yet, the developer or the DBA can trigger it via PowerShell or REST API and do it themselves. Fantastic. So now digging more into intelligent infrastructure. And so what is intelligent infrastructure? Basically, collect and align log data. Then we have to analyze patterns, do predictive modeling, and then prescribe solutions, and of course, automate the solution. And of course, those all go down to automation process. We go to the people, and people go execute, and then it interfaces with the infrastructure. Our goal is not to remove the people, but have it. We're moving people, yes, right for the infrastructure, but we're still going to manage it from a big picture. Nobody actually loses their job out of this process. What it is, we're just going to make it so you have more time to do innovation. And that's what people worry about with all these changes. So we're going to use machine learning and AIOPs to basically, or machine learning and artificial intelligence to directly optimize these components. We've seen this before. So we have a call about the operational burden. We talked about all those different things versus the innovation processes. Let's go talk about taking a trip with the family. First, back in the day, we had hardware. We all had the car, and we had the drive. The driver drove the car. We had the map for how we're going to get there. First version, we had external software, which is basically having a GPS with telling us how to get there properly, which was fantastic because now it has less time stopping, looking at maps, this kind of fun stuff. Then we moved to things with like Waze, which told me, hey, there's actually a traffic accident ahead. Here's a faster route. So we still had software with some machine learning, told us of a better way of doing things. Then, of course, we started having some hardware with some rules-based automation processes in there, i.e. lane assist, the backup cameras, the things that changes us to let us know that there's somebody next to you, don't get over, automatic braking in case something happens, those things, which moved so less and less time from the operational burden and more time for the systems to run. And then we moved to the same point where we had hardware integrated with machine learning properly, i.e. the Tesla and or self-driving automobiles. Now let's go turn that around for you and how you, in your life kind of stuff. So you as the information, we had hardware. We had to do one-to-one management. Then we added different kind of software to help manage many of these things, and it helped lower and save time, but it didn't save massive amounts of times. So we added external software with machine learning, i.e. some stuff, things that help, like a lot of third-party tools do a lot of that software-wise, tell us, make recommendations on where things go, like in moving virtual machines around to where it belongs kind of stuff, using recommendations on which queries you need to go tune, this kind of stuff. So this is a lot of things in here, which is part of the AI operations. But as we move the hardware with rules, we can now do more and more and have the things merge together. And as we do more of that, things will auto-tune. Think of all the claims Microsoft has made over the years about when the DBA goes away. The DBA never went away, and it's actually more DBAs today than it ever has been. What this does, again, it stops the DBA from having to focus on managing growing of databases, sizing considerations, performance-wise. We can just now focus on big picture architectural design of the database. We don't have to spend as much time doing things, i.e. making backup copies and copying over there, not to mention the restore testing processes. We can have that all automated. So, intelligent infrastructure or infrastructure intelligence is AIOps, machine learning, and rules-based automation, which, of course, for us means we're now taking the innovation screen and increasing that and lowering the operational burden. So we have less things to worry about, or less work, or the manual, mundane, repetitive tasks, and more time to focus on things that are going to provide more value for the organization. We all know what this is. We've all seen, the Garmin. We kind of mentioned the last thing, which is basically the first process. Again, it did data collection, it did pattern analysis, it did predictive modeling, and then it prescribed our route. But you, the driver, still had to do the turns. Now we have the same process. Only thing changed is the autonomous execution of route. In other words, we now have the car doing this. So the car from here, we upgraded it, made it better, just like storage today. We used to have spinning disks, now we have all-flash arrays. So we've upgraded into all-flash arrays, faster vehicles. Okay, yes, we can put this in there. Versus we now have, again, self-driving vehicles. There's a complete difference between any, no matter how fast, even if I go put a nice Maybach in here instead of a Gremlin, I had to throw in a funny car just because it's kind of fun. Versus a self-driving car. The amount of human interaction is very, very different.
But even on that car, it's funny you got it showing a car from the 70s because, if we put a modern car, with the exception of a Tesla and the next generation ones that aren't on the road yet, these cars are predominantly the same. There's a little bit of assistance in there, a little smoother ride, a little quieter, but it is still human operated, more or less the same as it's always been. We've got some external help from a GPS and things like that, but I could take that GPS Waze and jump in that Gremlin and navigate point A to point B in any modern car today with more or less the same experience. And then that massive shift is going to that autonomous, hey, now the car is driving itself. Now it's completely different. They're similar, that they got four wheels, but this is now we've just completely flipped everything on its head.
Right, and this is what we want you to think about from a database management perspective of all the different storage tasks you have for your database and all the different things of moving things around. Now, if it just worked for you automatically and did the things you needed to be done. And that's what we're trying to show you, what is possible and how we're doing it today. So AIOps, the fun part about this is there's gobs of different vendors involved, and they all have their own processes in that. And the worst part is we get this number, and we see all kinds of things of automating the solutions, and we're running different arrows back and forth with different people. I mean, just lots of arrows, no matter what vendor you're using and how many different vendors you want to pull into it. Short version, AIOps is complicated. The intelligent infrastructure is a lot simpler. And of course, back to doing more with less. Now, I'm sure many of you have a lot of questions. So October 7th, Rob and Shawn are going to actually do a Meet the Experts kind of stuff, and you can have open Q&A and ask us any question you want to. Here's a registration link for you to go to, sign up for it, and you can show up on it. And again, any question you want to talk about SQL Server or how intelligent infrastructure will work for you.
And I'd encourage you to join that session. If any of this sounds too good to be true, or you want to blow the BS whistle on us, feel free to. We're very proud of what we're producing here at Tintri and stand behind it, and would be happy to engage with you and share with you, answer questions. Just really want to thank you for your time.
Yes, appreciate it. Thank you all for attending and watching our video.
Yeah.
Bye-bye.
Bye. Thank you.